Alright, welcome again in another tutorial of the topic integration. So in this tutorial we're going to see some geometrical and dynamic applications of integration. Sasa remember, integration we have said is just the inverse of differentiation. Okay, we have discussed this in the previous tutorial. Kwa hiyo sasa, kama ambavyo differentiation ilikuwa na applications, vile vile integration ina application. Lakini sasa kitu kimoja ambacho nataka ni introduce, tulisema kwamba ukidifferentiate a function f of x with respect to x ukapata the derived function. Tukasema ukiintegrate hii derived function with respect to x, tumesema utapata the original function plus c. Sasa hii nilisema c maanake ni kwamba you have many solutions, kwa sababu c can be any number. Sasa hii inaitwa the general solution. Sasa nikipata value ya c, if I get the value of c, let's say nipate c ni 4 au 0, nika eliminate hii constant c, manake hiyo ninayoipata inaitwa particular solution. Sasa hii particular solution inapatikana kama umepewa some conditions, okay? So kuna examples here I will give and we will solve that will help us to learn the applications of integration, but also how to determine a particular solution from the general solution. So let us see this example here. Here for example 1, it says the gradient of a curve at any point is given by huyo hapa. Kwa hiyo you remember video ya kwanza ya topic ya differentiating gradient of a curve ni hii. So equation of a curve bila shaka itakuwa ni y sasa na something, okay? So anasema find the equation of the curve, lakini ametupa a condition. Okay? Now this condition inasema kwamba the curve passes through the points 1, 1, okay? This condition will help us to determine the particular solution. So now integration is the inverse of differentiation. So manake nikiintegrate hiyo 2x minus 1 hapo, manake nitapata original function ambao ni nini? Ni y. So I want to integrate 2x minus 1 with respect to x, and then I get y. So tumesoma integration of polynomial expression ni hivyo manake unaweza so 1 times dx unaacha tu hivyo. So we said unaweza ukatoa constant nje, just remain with that, is equal to y. So ukiintegrate x, tulisema kwamba if you integrate x power n with respect to x, ni sasa tuna x power n plus 1 over n plus 1 divisha c. So you are going to have x squared over 2, so is 1 plus 1. Minus, hii tulisema ni x, we have already differentiated it, plus c is equal to 0. So 2 and 2 goes. So our general solution now is x squared minus x, 8 is 0 up, I'm so sorry. It's not 0 there. Is y. So our general solution now is x squared minus x plus c is equal to y. So this one is our general solution, okay? So this one is the equation of the curve, okay? Kwa hiyo ulipewa gradient of a curve, kwa kuintegrate ile gradient of a curve tumepata nini? The equation of a curve. So remember the equation of a curve is y is equal to f of x, lakini the gradient of a curve is dy dx. So let us find the value of c by using the condition we were given. So akasema kwamba the curve passes through x equals to 1 and y equals to 1. So the general solution tumepata ni x squared minus x plus 1, plus c is equal to y. So when x is 1, okay, y is also at 1. So here we're going to get 1 minus 1 plus c. Hapa hamna square hapa. Where hapa. Okay. So when x is 1, you can see x hapa hamna square, okay? So 1 square ni 1, 1 plus c sasa na 1. So 1 minus 1 is 0, unapata c is equal to what? To 1. Kwa hiyo tumepata value of c. So we get the particular solution now. X squared minus x plus 1 is equal to y. So this one now is the what? Is the equation of a curve. Sasa hii equation of a curve tumeipata hapa, haina constant c wala nini. Okay? Inajibu moja tu, so ndo inaitwa the particular solution. I really hope you have understood. Let us see this example. If you haven't understood this example, the second example now will totally get you. So it says, a particle move on a straight line OA, and at time t the distance x from A, and at time t it is distance x from O. X is positive when it's on the same side of O as A. So it says write down the expression for the velocity v and acceleration f of the particle at time t. You also say find the distance x at time t if f ni acceleration, remember, okay? Velocity of v. You can see here f is acceleration. Given that v is 6 and x is negative 1 when t is 0. See, this is the condition. So this condition will help us get a particular solution from a general solution. Lakini nasema also show that the particle is stationary at O when t is equal to half. So he says a body moves from O to A. So at time t, it is at distance nini? X from O. So x is positive. So I'm write down the expression for velocity. Velocity manake ni hii hapa. Tulishasoma kwenye differentiation. Na acceleration kumbuka ametumia f, manake ni velocity sasa ndo na differentiate. And then anasema f acceleration ni sasa na 48t minus 24. Anasema hivi, find the distance x sasa from here hapa you can see that differentiation is the inverse of integration. Kwa velocity will just be integrate sasa f dt, okay? So velocity now, natafuta distance lakini first I have to find velocity, okay? Itakuwa sasa na ni integrate now 48t minus 24 dt. So hii integration of polynomial expression inakuwa hivi, okay? So natoa constants nje hizo, nabaki na velocity is equal to 48, we have t dt minus 24 dt. So t power n dt ukiintegrate tunapata nini? t power n plus 1 over, so nimebadilisha tu variable, baada ya x imekuwa t. Kwa hiyo na hapa sasa itakuwa ni 48. So t power 1 plus 1 ni t squared, 1 plus 1 ni squared, minus 24t plus our constant. So this and this goes. So our velocity now is equal to 24t squared minus 24t plus c. So this one now is the general solution for the velocity. I want the particular solution. I need to go back to the condition ambazo tulikuwa tumepewa kwenye swali. Alisema v is equal to 6 when t is equal to 0. Manake v is equal to 6 when t is equal to what? 0, like this. So you can see 0, 0 goes, c is equal to 6. Kwa hiyo velocity sasa, the particular solution ni hii hapa. So maana c tumepata 6 kwa hiyo badala ya c tena unaandika 6. So this now is a particular solution for what? For our velocity, okay? But remember, velocity is equal to dx dt, okay? Distance, x ni distance. And amesema find distance actually, akusema find velocity. So distance now, manake ni integrate velocity, okay? Kama kupata velocity na differentiate distance, manake kupata distance na integrate velocity. Integration is the inverse of differentiation. So now, my distance now, it means I will have to integrate my velocity, which is 24t squared minus 24t plus 6 dt. So it's a polynomial expression. Itakuwa ni 24t squared dt minus ni integrate 24t dt minus ni integrate 6 dt. So I take the constant outsides. Hapa nabaki na t squared dt minus t dt minus like this, okay? So now nikifuata ile formula yangu, I'm not going to write it again. Hapa nitakuwa na t3 over 3. See? n plus 1, n is 2 now. Minus 24. Here we're going to have t squared over 2 minus 6t plus c. So 2 goes, minus 12. 3 goes, minus 8. So our distance now, hapa ni jumlisha hapa. Unaona jumlisha. Hiyo negative hata sijui nimeitoa wapi. So ni jumlisha. So now our distance is going to be equal to 8t cubed minus 12t squared plus 6t plus c. Lakini hii sasa ni general solution, okay? General solution. So na c haijulikani, general solution. So now we must find the particular solution. Make find the value of c. General solution, make there is more than one solution. So we need to go back to the condition. Asema x is equal to -1 when t, unaweza kurudia pale kwenye swali, is equal to 0. So x is -1 when t is equal to 0. Kwa hiyo ipo hivi. Kwa t ikiwa 0, x ni -1. So you can see that c is equal to what? -1. So finally now, our distance is equal to x, sasa na 8t cube minus, distance ni x, okay? Minus 12t squared plus 6t minus 1. So this one now is a particular solution for the distance. Lakini swali halijaisha hapo, tumeshapata tu. Kuna pale mwisho anasemaje kwenye swali? Anasema kwamba show that the particle is stationary at t. Anasema show that the particle is stationary, kwa sehemu ya mwisho ya swali. unaweza kurudisha nyuma, utaona tu video yako. Sasa stationary maana yake nini? Maana yake is not moving, okay? Kwa maana yake v sasa na 0 at t. So turudi kwenye v yetu. V tulipata nini? Tulipata ni 24t squared minus 24t plus 6, ilikuwa ndio hii. So now at t is equal to have, show that v is equal to, at t is equal to 1 over 2, show that v is equal to 0. It's just simple. So v itakuwa sasa na 24 1 over 2 squared minus 24 t si ndio hiyo plus 6, okay? So v itakuwa sasa 24 1 over 2 squared is just 1 over 4 minus 24 1 over 2 plus 6. So divide by 4 here, 1 by 4 6, by 2 is 1, by 2 is 12. So you get 6 minus 12 plus 6, okay? So 6 plus 6 is 12 minus 12. So v is 0, hence proved. Okay? So maybe kwenye kusolve na kuongea, you know, I am solving and I'm also talking. Mtu unaweza ukachanganyikiwa, but when you integrate na ukapata ile c, okay? Infinite integral. Hii inaitwa general solution kwa sababu solution iko zaidi ya moja. Ukifanikiwa sasa kupata value of c, maana yake umepata solution moja inayohitajika. Maana yake hiyo inaitwa sasa particular solution. Na hiyo value of c unaipataje? Unaipata kwa kutumia zile condition ambazo umepewa. Kama ulivyoona kwenye hizi example ambazo tumefanyaje? Tumezisolve. Lakini sio hicho tu tulichojifunza. Tumejifunza pia applications of differentiation. You can see tumesolve swali la velocity, lakini pia tumesolve swali la gradient of the curve. So let me just say, okay, hiyo gradient of a curve na hiyo velocity ni same to your application ya integration. Let me just say now, see you in the next tutorial.